assumptions for four different non-parametric tests, statistical tests that are used when the data are non-parametric, when the data are not normally distributed. The first test is Mann-Whitney U test. The second one is Wilcoxon Signed-Rank Test. The third test is Kruskal-Wallis Test. And the fourth test is Friedman's test. Assumptions for Mann-Whitney U test, which is a non-parametric test, a test that is used when the data are not normally distributed. The Mann-Whitney U test is also known as Wilcoxon Rank Test, is a non-parametric statistical test for data that lacks normal distribution. It is equivalent to the two-sample independent t-test. The difference is that the Mann-Whitney U test only used for data that are non-parametric. So it is used to compare two independent groups. And it is used when the sample distribution are not normal. So when there are two groups and one of the group or two groups, the data in it are not normally distributed, then the independent t-test cannot be used, and Mann-Whitney U test is an alternative statistical test to use. So it is also used when the sample size is too small. So when to use the test? Use the test to compare two groups that are unrelated, not matched, unpaired, independent. Used when the data can be ordinal. Ordinal data is categorical data with order in it, such as the Likert scale, which is used in questionnaires and survey. Or the data are continuous, interval, or ratio data but lacks normality. So it is used when the data are not normally distributed or skewed to the right or to the left. The test can be used when there are outliers. Outliers are extreme, high or low scores or values that deviate from the rest of the data set. So to perform the test, hypotheses have to be generated. The null hypothesis will state that the distribution of the two groups are identical and the medians are equal. The alternative hypothesis will state that the distribution of the two groups differ. The way to accept or reject the null hypothesis is based on the p-value. If it is less than 0.05, then reject the null hypothesis. So what are assumptions? Assumptions are certain conditions that must be met prior to performing any statistical test to generate a valid and reliable result. Every statistical test have a set of assumptions. Violation of these assumptions, or if the one assumption or more than one assumption is not met or are not met, then the findings from the statistical test can be unreliable, which can lead to incorrect conclusion. So assumptions for the Mann-Whitney U test are that the sample should be independent, separate, unpaired. The response variable, which is the dependent variable, is continuous but not normally distributed or ordinal. the two groups have similar shapes, distribution, form, and data are not normally distributed. So there are 6 major assumptions that have to be fulfilled before choosing to use Mann-Whitney U test for the data set. The first assumption is that the data or the dependent variable can be continuous or ordinal. So the dependent variable measured at a continuous or ordinal level, continuous variables, variables that are on numerical scales such as revision time, exam performance, weight. Ordinal variable is a categorical variable but with order in it, such as the 5-point Likert scale that is used in questionnaires and survey, in which the response from participant is given on a scale from 1 to 5, 1 for strongly disagree and 5 for strongly agree. So there is a category in the response and there is an order. So it's called ordinal variable or ordinal data. The second assumption is that independent variable consists of 2 categorical groups. So there should be 2 groups, 2 categorical groups. They are unpaired, independent. Example, gender, male or female, employment status, employed, unemployed, smoking, is a smoker or non-smoker. The third assumption is the independence of observations. What does that mean? No associations between the observation or observations in each group of the independent variable or between groups. So different participants in each group. No participant participate in more than one group. So violation of the assumption, then you need to use the Wilcoxon Signed-Rank Test for paired sample. The fourth assumption is that similar data distribution shapes. There should be same data shape distribution for both groups of the independent variable. The fifth assumption is random sampling. The sample is collected randomly from population and the samples represent the population. And the sixth assumption is that there is no need for the data to be normally distributed. Non-normal distribution, it means that the test does not require normality of the data. The test can be used when normality is violated. Assumptions for Wilcoxon Signed-Rank Test, which is a non-parametric paired test. The test is non-parametric statistical test that is used to compare two related or paired or matched samples or repeated measurements on a single sample to determine whether there is a population mean ranks difference. So it is an alternative test to the paired t-test, as this Wilcoxon Signed-Rank Test is for paired samples. This test is non-parametric alternative to paired t-test when the data are not normally distributed and the assumption for the t-test is violated, which is the normality of the data. To perform the test, hypotheses will be generated. The null hypothesis will state that the median difference between the groups equal to 0, i.e. there is no difference between the paired samples. The alternative hypothesis will state that the median difference between the pairs is not equal to 0. To determine whether there is a significant difference or not, p-value will be calculated, and if it is less than 0.05, then the null hypothesis will be rejected. The advantages of using this paired non-parametric test is that it does not require normality of the data. So if the normality assumption is violated and the data are in two groups and those two groups are related or matched, then this Wilcoxon test will be the best to go for. The test is suitable for ordinal and continuous data that lacks normality. If the data are continuous and normal, then the paired t-test is the one to use. The test is also suitable to be used when there are outliers. Outliers are extreme high or low scores that deviate from the rest of the data set. What are assumptions? Assumptions are certain conditions or characteristics or criteria about the data that have to be fulfilled or met prior to performing any statistical test to generate a valid and reliable result. So every statistical test have a set of assumptions. Violation of these assumptions can lead to unreliable findings from the statistical test, which will eventually causes and produces an incorrect conclusions. The assumptions for the Wilcoxon Signed-Rank Test are: the data should be paired, the data measured on continuous or ordinal scale, the distribution of the difference score is symmetric, the difference between the two groups are continuous, not discrete. Continuous means that it can have fraction in it. Discrete, there is no fraction, it is an integer number. The differences are mutually independent and the differences can be ranked, and the sample is randomly selected from population. Those are the major assumptions that have to be fulfilled prior to performing this non-parametric test. So there are 7 major assumptions for Wilcoxon Signed-Rank Test that have to be fulfilled. The first assumption is that the dependent variable or data or the response or the outcome has to be continuous or ordinal. So the dependent variable is measured at an ordinal or continuous level. Ordinal variable is a variable that is categorical but with order in it, such as a 5-point Likert scale. Continuous variable with scores in it can be in a format of ratio or intervals. So ordinal variables are a variable with data that can be ranked, such as the Likert scale, which is frequently used in survey and questionnaire to obtain a response from participant. The scale can be from 5 points, Likert scale 7, and so on. And the response can be either strongly disagree or strongly agree, and so on. The continuous variable can be interval scale or ratio, such as revision time. For this test, the data has to be non-nominal. Cannot use categorical data for this test. Categorical data, a data that have categories in it, whether it is 2 categories, 3 categories, or 4 categories, as this test is not suitable for binary data or dichotomous data or nominal data. The second assumption is that the data should be non-parametric. So if it is a parametric data, then this test is not suitable, and that can lead to violation of the assumption for this test. So the data does not assume normal distribution. The difference between paired observation are not normally distributed. The third assumption is that there should be paired observations. The independent variable consists of 2 categorical, paired, related groups, or matched pairs. So it has to be 2 groups that are related, or a repeated measurement on the same sample. So measurement within the pair should be dependent, i.e. related, and each pair represent 2 measurements taken on the same subject or on matched subject, so that same subject are present in both groups. Example, those who participate in pre-test and post-test, same individual measured before the test and after the test. The fourth assumption is that the independence within pairs. So each pairs of observation are independent of each other, i.e. the outcome of one pair does not influence or affect the outcome of another. The fifth assumption is that the distribution differences is symmetrical. So the distribution of the differences between the 2 related groups is symmetrical in shape around the median, as here the median is taken as a parameter for estimation. Violation of this assumption, distribution of symmetry, then another test can be used, which is the sign test. The sixth assumption is the sample size. Small sample size can be used for this as it is a non-parametric test. So the test is suitable for a small sample size. And finally, the last major assumption is random sampling. Samples selected randomly from population, and the sample should represent population. Assumptions for Kruskal-Wallis test, or alternatively can be called the H test, which is a non-parametric test. The test is an equivalent of one-way ANOVA statistical test that will determine whether there is a difference between multiple groups, 3 or more groups. The H test can be also called one-way ANOVA on ranks, and it is a rank-based non-parametric statistical test. The test will determine whether there are statistical significant differences between the distribution of 3 or more independent groups. So to use this test, the data have to be sorted into 3 or more separate, unrelated, independent groups. The test will also compare the medians for each group. Since it is a non-parametric, then the mean will be used for comparison. The test is an extension of Mann-Whitney U test. The Mann-Whitney U test is a statistical test that is non-parametric. However, it is only used when there are only two groups, not more than two groups. More than two groups, three groups or more, then the Kruskal-Wallis test is the one to use. This is a test that can be used when normality assumption is violated. When the one-way ANOVA can't be used because the data is not normally distributed, then the Kruskal-Wallis test is an alternative test when the data are non-parametric. The H test can't determine which specific group or groups of independent variable are statistically significantly different from each other. So it can't tell which two or three or four or more groups that are different. It will only determine whether there is a significant difference between multiple groups, but without specifying which groups are different. So it can determine that at least two groups were different using post-hoc test. To determine which groups or two groups are statistically different, then the post-hoc test can be used. The H test does not assume normality in the data, so it is suitable for the data that are non-parametric. The test, which is Kruskal-Wallis test, is less sensitive to outlier than the one-way ANOVA. Outliers are an extreme low or high values that deviate from the other scores in the data set. The H test is used for non-parametric test. It doesn't require normal distribution of the data. The data can be ordinal or continuous. Ordinal data is categorical data with order in it, such as a Likert scale, which is used in surveys and questionnaire. Continuous data that has numerical scale in it, but is not normally distributed in this case. So the H test can be performed in a data that are ordinal or continuous. The test can be performed when there are multiple groups and it compare these groups that are unpaired, unmatched, independent of each others. So to perform the Kruskal-Wallis test, null hypothesis has to be generated, and that null hypothesis will state that all groups have the same distribution, which means that the medians across all groups are equals. The alternative hypothesis will state that at least one group differs. So there is a difference between those multiple groups. So if the p-value is less than 0.05, then reject the null hypothesis. So what are assumptions? Assumptions are certain conditions or criteria or features or characteristic of the data or about the data that must be met before performing any statistical test to generate valid and reliable results. Every statistical test have a set of assumptions or conditions that have to be satisfied or met. Violation of those assumptions can lead to unreliable findings, which eventually will lead to incorrect conclusions. Assumptions for Kruskal-Wallis test in brief are: groups are independent, observations are independent, dependent variable is ordinal or continuous, independent variable consists of at least two levels, two or more, and samples are independent and random, and the distribution in each group have similar shapes. So there are 5 major assumptions that have to be fulfilled or met before performing Kruskal-Wallis test on a data. The first assumption is that the dependent variable can be ordinal or continuous. Dependent variable can be measured on an ordinal scale or at a continuous scale that is not nominal but it is numerical and it is not normally distributed. The continuous scale can be interval or ratio. The second assumption is that independent of observations, which means that there is no relationship between observation within each group or between groups. So data within each group are independent of one another, and groups are independent, not overlapping, not related, and different participant in each group. That is the meaning for independent observations. Each participant belongs to one group. Violation of this assumption, then use an alternative test, which is Friedman test. The third assumption for Kruskal-Wallis test is independent groups. So the independent variable should consist of 3 or more categorical, unmatched, unpaired, independent groups. Example is the profession, in which the data can be sorted into groups such as doctor, dentists, scientists, pharmacists, and so on. Ethnicity, in which there are white people, black people, Asian, and others. Groups are independent of one another. There should be no overlap or paired relationship between those groups, so they are unpaired groups. So Kruskal-Wallis test can be used for just 2 groups. However, the best choice for 2 groups is Mann-Whitney U test, which is an unparametric test that can be used when there are 2 groups. The fourth assumption is that there should be similar shapes of distributions. The test assumes that the distribution of the groups have a similar shape, similar spread, similar skewness, as the data are not normally distributed. So if the distributions have the same shape, perform Kruskal-Wallis test to compare the medians of groups. Violation of the shape assumption, then use an alternative test, which is Fligner-Killeen test, and use post-hoc test. The fifth assumptions that have to be met for performing the test is sufficient sample size. So each group should ideally have sufficient sample size to allow for accurate ranking of the data. Each group should have at least 5 observations to ensure reliable results. If some assumptions are violated, then use bootstrapping. Assumptions for Friedman rank sum test, which is a non-parametric test that is used when the data are non-parametric, i.e. the data are not normally distributed. And the test is used also when the data are repeated measures, which means that the data are paired or match groups or dependent groups. So the Friedman test is a non-parametric test that is used for data that are not normally distributed. This is an alternative to the repeated measure ANOVA, which is used when there are matched or pair or paired groups or dependent groups, and when that data are normally distributed. The Friedman's test can be used when the data lacks normality, and the test of repeated measure ANOVA can't be used. The test also detects the differences between matched or related or dependent groups. So the groups have to be related, which means the same participant participate in each group. The test is based on using the median, and it ranks the data before performing the test. So it takes the data and put them into ranks and then perform the analysis on the data. An example of a repeated measure that can be used for the Friedman test is when we want to compare the efficacy of 3 different teaching methods on student performance, whether any of the 3 different teaching styles can enhance the student performance. Then the 3 different styles are the 3 different groups, but these groups are not different, they are related, as the same participant participate in each group, and the teaching style for each group is given a label. A second example is assessing the satisfaction of a group of people for 3 different surfaces. In this example, the participant participates in 3 different services, but those groups are related because the same participate in each group, but with different surfaces, to find out how satisfied is those people from these services, and which services differ from the other. This example can be used when the data are ordinal. And another example for the repeated measure data is analysis of repeated measures in medical experiment. It is very often that a drug want to be tested, and volunteers or participants are assigned to 3 or more groups, but these groups are related because the same participant participate in these groups, and testing whether the dose or the time of the dose can improve the efficacy of the drug. So there are multiple examples in a situation where this test can be used when the data are repeated measures, when the same participant exists in each group, but with different conditions tested for each group. To perform the Friedman's test, alternative and null hypothesis has to be generated and stated. The null hypothesis will state that the distributions of the groups are identical, which means the median ranks of groups or conditions are the same. The alternative hypothesis will state that at least one group differs in distribution, at least one group has different median ranks from the other. And then a p-value is calculated. If it is less than 0.05, then reject the null hypothesis and accept the alternative hypothesis, which indicates that there is a difference between the groups. So the things with the Friedman test is that it will try to determine if there is an overall difference or differences between the groups, for all the groups, without specifying which group is different from the other. So a post hoc has to be done if the p-value is significant. The post hoc test will assess pairwise group to find out the groups that differs. Assumptions. So this drags us to the main topic of this presentation, which is assumptions. Assumptions are specific conditions or criteria or characteristics of that data that have to be met before performing any statistical test to produce a reliable results. So each statistical test have a set of assumptions that have to be met or fulfilled. Violations of these assumptions can lead to incorrect findings and can lead to unreliable, incorrect conclusions. Some of the assumptions that are important for the Friedman test is that the independent variable has at least 3 levels in it, or 3 groups. The data come from related groups or matched samples, i.e. it is repeated measures from the same subject, the same participant participate in the groups. The samples are randomly selected from population, and the dependent variable can be ordinal or can be continuous. An ordinal variable is a variable is categorical, but there is an order in the category, such as the 5 Likert scales that is commonly used for surveys and questionnaires. Or the data can be numerical scale, continuous, but lacks normality. So the sample should not need to be normally distributed. So this test is designed for data that are not normally distributed. There are 8 assumptions that have to be met before performing the Friedman test. The first assumption is that paired related groups, which means that the test is for repeated measures data. Data have to be from the same subject under different conditions. This subject has been subjected to different conditions or criteria. Or those individuals are in a groups, but these individuals have matched or paired samples. They are each participant participate in each group. The second assumption is that the data are ordinal or continuous. The dependent variable should be measured at either an ordinal rank data or at a continuous numerical scale, and that can be interval or ratio. And if it is a continuous data, then this data should be non-parametrics, which means lacks normality, to use this test. The third assumption is that there should be at least 3 groups. So the independent variable should consist of 3 or more related or matched groups, i.e. repeated measurements, which means that the samples are matched. The fourth assumption is the independence within groups, which means that the observation within each group should be independent of each other. No influence or overlap between the measurement in different groups. The fifth assumption is that comparable measurement scales, which means that the dependent variable measured on the same scales across all groups. The sixth assumption is rankable data. The data can be ranked, which means that order does exist in the observations. The seventh assumption is that there is no distribution assumption, which means that the test doesn't require that the dependent variable have to follow specific distribution. So this test is robust for violation of normality, and it is used when the data are not normally distributed. And the eighth assumption is sample size, as the sample should be sufficiently large to perform this test. So what to do when the violation of the assumptions is being detected or observed? Then use non-parametric methods such as Wilcoxon Signed-Rank Test for two paired groups. This test is used for two groups, and these groups are related. Friedman's is used for paired groups, but for three or more groups, or alternatively use the Kruskal-Wallis test when the groups are independent. If you find this video useful, do subscribe to the channel, leave any comment in the indicated box, and activate the notification bell to receive the recent and latest release into the channel of several different video clips, and click on the like icon and share the video link with others so the channel can expand and improve to include a large scope of different statistical method and how to analyze data using several different statistical packages such as SPSS, Excel, Stata, Jamovi, RStatistic or Statistics, GraphPad, Prism, GPower, Python, and RevMan. If you are a student or a researcher and you have a data, whether it is quantitative or qualitative, and you want to perform statistical analysis on that data using any of the softwares listed here, whether it's SPSS, Excel, Stata, Jamovi, RStatistics, GraphPad, Prism, RevMan, GMP, Python, then do contact me to arrange for either a one-to-one private tutor session or a training course on any of these statistical packages. My contact details are given here, so don't hesitate to write to me or email me if you need a private one-to-one tutoring or a training course.